It is the end of a very long day, but in about 2 hours, who here is coming to Dead Mouse? Come on, raise your hands. Dead Mouse is the entertainment tonight. We launched that at the, we announced that at the keynote this morning. I'm hearing rumors of big 20-foot robots on stage. It's going to be one heck of a show. So I hope you all make it. No, you're good to go. Dead Mouse tonight. Big concert hall, check your agenda. We good? Everybody's coming, right? Everybody? Yeah. It's going to be one heck of a show with robots. All right, let's talk about snapshots, and when we talk about snapshots, we need to talk about EBS. Who here uses EBS on a regular basis? Good. While I've got you all in the room, who here uses only PIOps for their database workloads? Only PIOps for their database workloads. So while I've got a bunch of people that use EBS in the room, we're going to talk about that real quick. If it's a structured data workload, you use PIOps. Period. Done. Don't talk about it. You can say, hey, Craig, it's a little bit more expensive. And I'll say, it's that much more expensive and that much better. So it's completely worth it. So EBS is protected. We protect that on the back end. The average failure rate of an EBS volume is 0.1 to 0.5% per year. So it's durable, it's protected. That's roughly the same as, say, a RAID 5 array in a device in your office or on premise is roughly what it's equivalent to. Snapshots, though, are much more durable than 0.1 to 0.5% per year. Snapshots are stored in S3, which means they're stored on a system designed for 11 nines of durability. And 11 nines could be a hard number to wrap your head around. What that actually means is if you store 10,000 objects with us for 10 million years, there's a 50-50 chance we'll lose one of those objects. So S3 is durable, okay? And when we're looking at how durable is your data, when we're measuring the durability of your data, and you're taking snapshots, we say data created on the volume since the last snapshot has a durability of X, and data created before the last snapshot has a durability of Y. Y is much, much higher than X. So snapshots are important because they increase the durability of your data, and that is very important. They're differential, which means they're space efficient. The first snapshot you take is a clone. Every other snapshot you take is an incremental, which means if you've got 500 snapshots of the same volume and you've never changed anything on that volume, your cost is 0. So you don't need to worry about whether you're changing data, whether you're modifying data. You don't have to worry about that when you're going to take snapshots, because if you don't change anything on the volume, we don't charge you anything. Okay? And you say, well, Craig, I've got this big, long list of snapshots. And we're going to talk today about a project that you're all going to help me with to automate that process so you never have to deal with a snapshot manually again. EBS operates in a single availability zone. Who here is really, really good about making sure their applications are always in multiple availability zones? Good. That's very important. EBS, however, runs in a single availability zone, which means if we lose an AZ, which is possible, the data on that EBS volume is unavailable for the length of that loss. But if you've taken a snapshot and your snapshot's 5 minutes old, you can get to that 5-minute-old data because S3 is not AZ independent. So we just do a create volume -- snapshot, and we have access to that data a couple of seconds later. So that's very important. And we announced this year that you can copy snapshots across regions, and we copy the differential snapshots. So if you're taking, make a megabyte worth of change and then do a cross-region snapshot, that copy only takes about a minute because you only made about a megabyte worth of changes. So it's quick. Okay? So other reasons to take snapshots. You can version your application. Let's say your application is at version 1.2 today, and you're going to run an upgrade to 1.3. Right before the upgrade, you take a snapshot. That gives you a version-controlled version. That gives you an easy rollback plan, an easy rollback method, and it's really, really inexpensive, so why not do it? You should all have thousands and thousands of snapshots because they're incredibly cheap. right? The reason some of you don't is because management's hard, and we're going to work on that. And they're inexpensive, right? A snapshot costs less than EBS. Not by much. Standard EBS in US East is 10 cents per gig per month. S3 is 9.5 cents. If you're using PIOPS, it's a little bit more expensive, which makes the snapshots even less expensive. Okay. Managing an individual snapshot is easy. We have a great web console. The web console looks really well. We have some command line tools. There's not a lot to it. This is all you can do with a snapshot. You create it, you delete it, and recently we started giving the ability to copy it. You can do a couple of more things related to it. You can create a volume from a snapshot. But this is about it. So if you've got 1 or 2 snapshots, that's really, really easy. But what happens when you have thousands of them? What happens when you have a fleet of 5,000 servers and for some reason you want a snapshot of all the root volumes? Or you're running 500 MySQL databases and you want snapshots of all of those arrays. That gets really complicated. Plus, snapshots are versions. We talked about using them for version control. They're backups. And backups and version control should have life cycles. So your backup should have grandfather, father, son, or maybe even more complex life cycles. You should be able to maintain a certain number of versions. You should be able to say, I want so many dailies, so many weeklies, and so many monthlies. And because we can copy snapshots across regions really easily, you should have a life cycle that spans regions, right? We can imagine a place where you, on a regular basis, snapshot a root volume, copy it to another region, create an AMI out of that snapshotted copy, out of that copy of a snapshot, and then launch that AMI. And we can imagine that being a regular part of your process that happens on a regular schedule as part of your multi-region availability story. You also want to snapshot arrays. And snapshotting arrays can be complicated. I'm going to talk a little bit about that. So I want to introduce a project, an open source project we're going to launch next week called Arch. Arch will be available at the AWS Labs GitHub repo. This deck, all of the sample code, a demo I'm going to run through really quickly is all available in the deck, and you'll all get an email on Wednesday with access to the deck and the code and all the links and all that stuff. So we'll get all that to you. So this is an open source project. Right now it exists as a prototype that implements most of the functionality, but it's not ready for prime time. We're going to collaborate with you, the community, on this. And we're going to start that process here tonight, and then we're going to extend it going forward. Right? Hopefully a lot of you understand the open source model, the idea that we publish something, you clone it, you submit a pull request to us, we say, hey, those are some fantastic improvements, we accept them into the project, and we iterate like that forever until we have a fantastic tool. So we're going to work on that together. It has 2 primary pieces. It has Arch. Arch takes snapshots and manages the life cycles of that snapshot, which essentially means it takes a snapshot, determines whether that snapshot should be copied to another region, determines what snapshots have expired, and then deletes the snapshots that have expired. Pyrius is a command line tool that makes it easier to recover snapshots. So the goal there is you start a command line tool, it gives you a list of all of your snapshots, and you say, I want to restore this snapshot to this instance at this mount point. Okay? So one of the software principles I believe in is simplicity. So we're going to keep this as simple as possible. And the way we can do that is with tags. Tags are incredibly valuable. Who here uses tags on their resources already? That's great. That's good. So we use tags everywhere with Arch. So first of all, we don't want Arch touching volumes it shouldn't touch. So we have a tag that says Arch manages this volume. All that means is that our code has something to filter on, so it isn't touching all of your volumes, it's only touching the volumes you want it to. Second, in this iteration is retention. How long do you want us to keep the snapshots of this volume? Okay? Is this volume a member of an array? So Arch and retention are required values. If it's a member of an array, if you've created an MD-admin array or an LVM2 array out of this volume, you're going to say, this is a member of an array, and that string is /dev/md0 or md1 or something like that. It tells us what array that volume is a member of. And then if you want to copy it across regions, what region do you want to copy that snapshot to? Okay? One of the things I'm hoping the community will help with is a format there to do multiple region copies. So if you want to copy from the US East to US West and EU West 1, how can we extend this to do that? On snapshots, we keep quite a few tags. Another one to tell us that it's managed by Arch. The source instance, right? Where did this snapshot come from? Because right now, if you take a snapshot, all you've got is snap dash and then 8 numbers and letters, and that doesn't tell you much. So we need to know where this snapshot came from. What device was it mounted as? Right? We can get that programmatically. It can be useful in a couple of different places, especially if we're going to reassemble an array. So programmatically, we're adding these tags. And then the expire date. We do that programmatically. It's actually really simple. We take the date and time that we took the snapshot, we add the retention to it, and that gives us the expire date. And it tells us when we can expire the volume, the snapshot. Was the snapshot a member of an array? We need that information to put it back together. And if we've copied this snapshot from another region, what region did we copy it from? Okay? So we've got a quick demo, and I want to show you some of the code. We were having AV issues, so bear with us. Because computers are hard. All right, there we go. So I'm going to SSH into the instance. If nobody uses this, it's kind of cool. It's something called duo push. I kind of like it. So I SSH in. It uses force command to prompt me with a prompt. I press 1. I get a little pop-up on my iPhone. And I say, yes, I approve the login. There we go. Easy dual-factor authentication. It's free to 1,000 logins a month. So that's duo security. It's actually pretty neat. All right, so the demo is not terribly exciting, right? Arch starts. What it's doing is it's getting a list of all of the volumes in my account. It's looking for a list that are managed, and it's taking snapshots of every managed snapshot, of every managed volume in my account. I think it's going to do 2 or 3. I didn't want this to take too long. We'll talk about that. We'll talk about that. And then it deletes the snapshots. Okay? We had a question. Does it freeze the file system? No, it doesn't. We have an architecture that will allow that, and we're going to talk about how we can implement that. So when we implement prototypes at AWS, we do it at a really high level with the easiest language we can. So this is done in Bash at the moment, so it's really easy to read. Right? Could not be easier. Right? And this manages the life cycles for tons and tons of volumes. I'm using this code to manage my account, and that's got right now about 3,000 instances running in it. And it takes snapshots, it manages snapshots, and it deletes snapshots. So we start off really easy. We get everything that's managed by Arch. Then we take a snapshot of it. That's really easy. Then we create some tags on it. That's really easy. Then we build a string, and we stick the expire date on it. And like I said, the expire date is just today's date plus the retention that was on the volume. So it's incredibly straightforward. And then we identify those snapshots by building today's day of year and the expire target. I'm going to show you what the expire target looks like real quick. So let's find a snapshot I just took. Look at the tags. Here we go. So this is what it actually ends up looking like. So we've got, it's managed by Arch. We have the source device, and the source device is important because when we go to do a restore, we're going to attempt to attach it as the same source device. That can be important if you're using MDadmin or LVM2. So that's why we're tagging it with the source device. We have the expire date. The format on the expire date is very simple. It's the year and the day of the year that we can expire the snapshot. By taking dates, times, and seconds out of it, it makes it really, really easy. It does mean you need to run the tool at least once a day, but there are ways that we can modify that so it's more flexible. And I'm going to talk to you guys about what you want to see here. Right? This is a collaboration. And so I'm hoping that there are some of you. Well, let's ask the question, who here participates in Git projects that are not their own? Oh, that's good. Who's going to help me with my project? There we go. Everybody clap. That's good. This isn't me being lazy. This is me helping you help yourself. That's what this is, and I'm excited about it. And then the source instance, right? And on the source instance, this is important because it doesn't do you any good to just have a snap. You need to know where that snapshot came from, and that's what's important. Okay, so I want to start collaborating now, right? How many here use simple workflow to manage stuff? How many know, that's not very many, how many know that you can use simple workflow as an enterprise class cron? You use that? Yes, we have several people that use simple workflow as an enterprise class cron. So this needs to run on a regular basis, so we're going to build it based on simple workflow. So with simple workflow, we've got a bunch of choices. The first one is language. We have Java, Ruby, and Python. Who here thinks this should be written in Java? Yeah, you're standing alone, aren't you? Who here thinks Ruby? Good, I'm okay with Ruby. And who says Python? Oh, Python it is. Python it is. So we'll write this tool in Python. How many people, let's ask some questions. How many people want snapshots of every root volume by default? How many would see value in ignoring the Arch tag on root volumes and creating snapshots for root volumes by default? Okay, some. How many of you have RAID arrays? How many of you created arrays with MDadmin? Okay, all right, let's talk about that. There's a concept of quiescing a file system. So you have lots and lots of writes happening to your file system. And let's look at a database example. You open up a page to write a page to disk, and we get half of that page written to disk, and then we take a snapshot. The snapshot finishes, and we write the rest of the page to disk. When we go to use that snapshot, it is utterly and completely worthless to us, and that's no good. So we need to quiesce file systems in order to do that. How many of you use XFS? Everybody here who cares about quiescing file systems should be reusing XFS because it's the one popular open source file system that we can quiesce with XFS. So in order to quiesce with XFS, we need to coordinate. We need to take our simple workflow that's managing our snapshots, and we need an agent on every machine that quiesces the file system, tells simple workflow to take the snapshot, and then releases the quiesce. Does that make sense to everybody? Okay, all right.
Yeah, the question is, by the way, since kernel 2629, which was a long while ago, ext4 supports that as well.
So we can quiesce with ext4 as well?
And ext3.
Okay, I can't keep up, I apologize. How many people are doing quiescing now with something other than XFS? So we have some people doing it. Okay, good, thank you, I've learned something, thank you. So we need to quiesce arrays of snapshots. How many people have an array more than 6 volumes? Wow, more than 10 volumes. Is that a PIOPS array of 10 volumes? We should talk later, because that's really fast. Okay. That's really fast. So let's talk a little bit. What's that? Okay, RAID 6. Oh, we should talk about parity-based RAID. Let's talk real quickly. So my presentation is short. I want to get you guys excited about the project, and then we're going to publish it next week, and you guys are all going to start doing pull requests and going to start improving on it. So my presentation isn't super long. Let's talk about parity-based RAID with EBS. When you create an EBS volume, you're going against a piece of hardware somewhere. You create another EBS volume, you're going against a piece of hardware somewhere. There is a chance it's the same piece of hardware. So when you create a parity-based RAID array using EBS, there's a chance that your data and parity volumes are on the same piece of hardware. And because of that chance, You cannot calculate the increased durability of your data with a parity-based RAID. If you can't calculate it, you must assume that it is 0. So you're taking a performance hit for building a parity-based RAID, and you cannot quantify the increased data durability. So it's our suggestion that you build RAID 0 arrays. Don't worry about RAID 5, don't worry about RAID 10, don't worry about RAID 6. Build RAID 0 stripes. They're much, much faster. A RAID 0 stripe on a HPC instance can do 800 megabytes per second to the EBS fleet. We announced that a couple of weeks ago. It's incredibly fast. So don't worry about parity. Don't just do a RAID 0 array, and then we'll quiesce it and snapshot it on a regular basis. So I want to open things up for questions before the Dead Mouse concert. Any questions? Yes, sir. So that's a good question, and I had to noodle on that one for a little bit in my prototype. If you look, we're doing expire day. We're adding the current date to the date, or we're adding 10 to the current date, which means date converts it for us. And I've tested that. So word wrap is handled. So if I add 100 to today's date, it gives me 2014 as the year and 54 as the day. So we tested that. All right, other questions? Yes, sir. There's a limit of 10 tags per resource. What we could do is we could combine tags. So I could have a single tag that said Arch, and then I could say 1: the device, the expire date, the source date, . Who here uses enough tags already that us using 6 tags would be a problem? Guess what's going to happen? When I publish this next week, it's going to be a single tag for Arch, and I'm going to separate all of the data. Does that work for everybody? Yay. Okay, done. That's why collaboration is awesome. And I'm going to do it in Python, so it's even better. It's even better. Although, who here uses our new command line tools? I got to tell you, those things are fantastic. They're based on Python, so they're really, really fast. And is everybody familiar with this guy right here? Okay, so that's the trick. And it's taken me a little while to get used to it. JQ, so there is a dash query option, and I haven't used it yet. So you're saying that that's even better? Okay, all right. I'm learning things. It's fantastic. As a matter of fact, hold on. We're good at it. We're good at our jobs, right? You said dash query. So right now, if I run this, I get back a JSON document. And a JSON document's fantastic, but trying to parse it and pipe it and do things with it in Bash is tough. So you said dash query. Recent versions. Okay, well, hold on. We're good at what we do, right? Bam! We're going to try it again. I love live demos. This is going to crash and burn in a minute. I just feel it deep in my soul. So while that's running and we try this out, other questions? Yes, sir. How do you handle high rates of change and limited copy slots? What do you mean limited copy? The question is, how do I manage high rates of change and limited copy slots? And my question is, what do you mean limited copy slots? You only copy 5 volumes to a different region at a time. That is a soft limit. So that is the default limit, and lots of things that we do at Amazon have soft limits. If you need that limit raised, come find me, I'll give you my card, we'll raise that limit for you. All right? So the number of simultaneous volumes that you can copy to another region is 5. Again, that's a soft limit. The same as when you all opened up your account for the very first time, you could only run 20 instances. You called somebody, we raised the limit, we'll raise that limit for you as well.
We have a security requirement to completely destroy instances at some period of time. So let's just take a 1-month period. We're going to completely destroy an instance and replace it with a new one.
Sure.
Running the similar type of workload. Let's use a database in this case.
Sure.
Can we make that snapshot not tied to an instance, but tied to some function?
That's really interesting. So for general purpose, so the question is, yes, and I think I have a way to do it. So the question is, I destroy my instances every 30 days, and I replace them with a similar instance. And I do that for security reasons. And that's a good reason. Let's say a machine's been rootkitted. If you have a policy that every instance disappears after a week, the threat surface shrinks. Okay? So in your case, what I would do is I would probably fork it, and I would say instead of instance ID, I would create a tag on those instances that is the whatever it does, right? This is the instance that's doing this thing. And instead of copying instance ID, I would copy that tag to the snapshot. Does that make sense? Okay, hold on. Oh, all right. I believe you completely. I do. So looking for a query option? Where, hold on. It should be in the repo. It should be in the repo. This is really not the forum for this at all. Okay, so it requires a filter. So if you do query, it requires a filter? Okay, all right. But similar to JQ. All right, so that's a good place to start. We will look at, we're not going to launch this in Bash, obviously. I love Bash. Bash is one of my favorite languages. Error handling is just a disaster. So I will look at that. Thank you. Other questions? Yes, sir.
Yeah. Can you elaborate on the atomicity of the snapshots?
What's that?
The atomicity of the snapshots.
Sure. So you're going to do an EC2 create snapshot, and you're going to get back the question is, talk about the how atomic are snapshots. And the answer is, you issue the command, and then when you get back the snapshot ID, when we started sending you the snapshot ID is when we locked changes on the snapshot that we're creating. Does that make sense?
Yeah, but I mean, there are some software that can survive partial page writes.
Oh, okay. Yeah, that's quiescing the file system. So you will need to quiesce the file system. So we do an XFS quiesce, then we do a create snapshot, then we do an XFS release the quiesce.
Yeah, but there are some software that can survive a partial page write. Like,
sure.
For example, the PostgreSQL database with full page writes.
Right.
But still, snapshots may be, as far as I know, inconsistent because they're not fully atomic.
So snapshots are crash consistent is the way to consider an EBS snapshot. It's crash consistency. So I'd have to understand why a file system quiesce wouldn't do it for you.
Oh, sure.
Okay, yeah. So let's assume you're going to do file system quiescing. I think it's the way to solve that problem. Okay. Oh yeah, let's talk. I'm sorry, I didn't explain file system quiescing really well. So you've got a file system, you're doing lots and lots of I/O to it. When you issue a quiesce command, it starts sending I/O waits up to the application for writes. Reads continue, the application starts to get I/O waits. Okay? All of the buffers, kernel buffer, application buffers, all of the buffers get flushed down to the disk, and then it does an F-sync. Then we take a snapshot. Then we release the quiesce so writes can start again. That usually takes 200 or 300 milliseconds. Your application is going to handle it just fine. That's a file system quiesce. Yes, sir.
Hi, I've been maintaining the open source project EC2 Consistent Snapshot for the last 5 years.
Hold on, put the thing down. Put the thing down. Everybody clap.
And I'm happy to,
Eric,
Hammond.
right? This is Eric Hammond. I recognize his name because I use that tool on a regular basis.
And I've learned a few things that customers and users of the tool want over the years, and I'd be happy to share them with you. Also, EC2 Expire Snapshots has a interesting...
Yes, it does. Thank you, Eric.
But I'm happy to turn over the entire thing to somebody writing in Python, please.
Yes, yes. And so EC2 Consistent Snapshots, if you wanted to do this today, is the way to do it. It's the canonical tool for solving this problem, right? And another thought, shout out to the Ubuntu folks, they wrote Cloud Init. Cloud Init is the way that your instance works when it launches. It's the foundation behind CloudFormation. It's an incredible tool. So again, for the Ubuntu project. Yes, sir.
Only indirectly related to snapshots. I've been running a dozen EC2 instances for the last year and a half, 2 years. And 3 weeks ago, I got a message from Amazon saying one of the instances was going to be retired in 36 hours, and that was it.
36 hours.
36 hours.
Okay, so that's unusual. Let me explain what happened. Your instance is running on a piece of hardware. That's just the way it is, right? It's running on a piece of hardware. Chances are a power supply went bad, a drive died, something went wrong. Okay? So if you get one of those notes and you're like, yeah, 36 hours or 2 weeks or a month, I can't do it, right? Everybody in this room has support, basic level support. It covers this. You open up a support case and you say, I can't do it in 36 hours, give me 30 days. And what we'll say to you is, I hope, please don't tell me I'm wrong. What we'll say to you is, okay, but you're running a risk of a spontaneous failure.
Well, the solution was to snapshot the attached volumes, and then I created an image from the running instance and built another instance from that image, and everything was fine.
There you go.
But I didn't get an explanation of why, and so thank you for that.
Yeah. So again, we're providing a service. We want to hide that from you, but you are running on a piece of hardware ultimately, and that's what happened. That's what broke.
Sorry, normally it's not necessary to take a snapshot because the retirement or the retirement is because of the underlying load from the instance. So it's okay to just stop the instance and boot it up because it will move to another host then, and then you're fine with retirement.
You could have done that too. If you'd gone to stop the instance or shut down the instance and then started it again, that would have moved it as well.
If it's EBS backed.
If it's EBS backed. What's that? Yeah, you can absolutely do that in Classic.
Yes, you can.
All EBS backed volumes, absolutely.
I've done it all the time.
Yeah, instance backed, you can't snapshot an instance. Who here uses a lot of instance backed volumes, instance backed snapshots? Not a lot. We don't see it a lot. It has some use cases. The spot market, it's popular in the spot market. Let me ask a question tangential to that. How many people think that there is value in whenever we snapshot a root volume with this tool, we automatically turn it into an AMI and put it in your list of private AMIs so you can restart it? How many think that's valuable? Okay, how many think it should just be an option that you pass in on a tag? Done. Done. All right, yes, sir. Oh, so here, we have a requirement now. We want to take a snapshot, copy it to another region, turn it into an AMI in that region.
That would be.
So we can absolutely do that as well. Done. Yes, sir.
How do you propose handling quiescing applications such as databases?
So that's a really good question. Eric's project quiesces, I believe, MySQL and MongoDB. That's it, right? Right. So I think what will happen is we'll build the tool in a way that you can add hooks to quiesce various applications, and then the community will say, oh, I want a hook for this, submit a pull request, and I'll pull it in. Does that work?
Yes, it's perfect.
Done. Yes, sir.
So you started this talk talking about the AFR for EBS volumes.
Yes.
But what about availability of individual volumes where the
availability of an individual volume is equal to the availability of the availability zone it runs in, and we do not have an SLA around the availability of an availability zone. Say that 3 times fast. Does that answer your question?
Well, I think we're building large RAID 0 arrays. If one EBS volume starts going out to lunch, it hurts your entire RAID
Yes,
group.
it does. Yes, it does. So the availability. So the easy answer here is, and it gets a little bit more complicated in the details, but the easy answer is that an EBS volume will be available as long as the availability zone is available. There are very, very few failure scenarios where a volume becomes unavailable, but the data isn't lost. Does that make sense? It's either available or completely failed.
So can you quantify very, very few when you quantify very, very small AFR?
The party line is that the availability of an EBS volume is equal to the availability zone in which it resides.
So it's more of a light switch than
Yes,
just
absolutely.
that one volume. Okay.
Absolutely.
Thank you.
Good, thank you. What's that? You should leave now, thank you. Please feel free to exit the door. Yes. We are constantly working to improve our services, and I can assure you that that was a motivating factor. And we wrote a great big outage report. It's actually, if you guys are sort of infrastructure geeks, search for the outage report. It's about 3 pages long. We expose lots of details about the way that we operate and the things that we were doing to fix it. Okay? Yes, sir.
We use LVM, and we regularly restore the entire volume group, but not an individual disk. Would it be possible to add a tag for the volume group?
Yeah, I would think if we were doing LVM restores, who here uses MDadmin for arrays? And who uses LVM? All right, so it's a mix. I can't imagine, I think we would only support volume groups. I don't know why we would support individual disks.
Okay.
Yeah, I think you're good there. So the question was, in the details of how we'll handle rebuilding arrays with LVM2, the answer is we'll make it fairly easy to do. Yes, sir.
So when you take a snapshot, what happens when the snapshot is still in progress and data changes in the volume? Like, I'm very curious to know, like, what really happens behind the scenes. Let's say you're at 90% of progress,
sure,
and then you change, like, I don't know, like 80% of the contents of your disk. I mean,
yeah,
what would I find in the snapshot?
Oh, the snapshot is consistent at the time you issue the snapshot command. So you would not see the new data in the snapshot. So let's say that a snapshot takes an hour. You take a snapshot at 1 o'clock and it finishes at 2 p.m. Changes between 1 o'clock and 2 p.m. will not appear in the snapshot.
Right, yeah, but...
they're just written to EBS.
Right, yeah.
You want to know how we make snapshots work?
No, I mean, yeah, well, I'd love to. But
yeah. We're hiring. It's awesome.
Yeah, but, so if the data is not copied yet to S3, I mean, so, and if I delete the data from the volume, I mean, I really don't expect to find it in my snapshot. You see what I mean?
Yes.
So, I mean, this is true, right?
You take a snapshot at 1 p.m., you delete a whole bunch of data, and 10 minutes later the snapshot finishes, you will find that data in the snapshot.
Okay.
It's awesome, I'll tell you.
So, yeah.
Somebody yelled out the answer earlier.
What's that? Sorry?
Yeah, so go to Wikipedia, look up what he said, because I can't say it, and that'll explain to you how snapshots kind of work. Okay. That will explain to you how snapshots appear to work for you. It's a functional explanation for everybody in this room. How about that? Yes, sir.
So I come from a healthcare company that we have to store a lot of patient data securely. And one of the things I'd love to see with this is some way to tag it and have it automatically go to Glacier, because you have these large file systems that you have to keep on file for 7 years. And I'd love it to automatically be able to go into Glacier versus individually putting that AMI to Glacier myself.
So writing snapshots to Glacier is something we hear from a lot of customers, and I'll pass your feedback along to the EBS team.
Thank you.
Thank you. Yes, sir.
What a wonderful opportunity to ask a question. I come from an environment that's about half Windows, half Linux. Does anyone else in this room have any interest in having VSS quiesce as part of this? Wow.
Yes, that was my question.
I don't know how to write a VSS provider.
Okay.
I've looked at it. It appears to be arcane and horribly documented, and I'm not a Windows guy.
Sure.
If somebody in the community wants to write a VSS provider, I'd be all about it. I'd encourage it. I think it would be great.
Yep.
Yeah. Yeah. So just so everybody knows, to quiesce a file system in Windows, you have to have something called a VSS virtual shadows. Volume shadow service. I'm hearing no. This room can't agree. Okay. You need a VSS provider. Right? And the documentation for writing VSS providers is fairly arcane. But if anybody wants to take a shot at it, I'm happy to redistribute it. Yes, sir.
We're running a MongoDB shard. Sure. So we have a MongoS server, a config server, and then the replica set, node of the replica set. How would we quiesce all of those volumes at the same exact time?
So simple workflow is fantastic at that. That's what simple workflow does, is coordinate lots and lots and lots of jobs. So what would happen is, say 10 seconds before you wanted to quiesce everything, you'd make sure the time on all the machines were the same. And simple workflow would say to those machines, at this time, quiesce, snapshot, release the quiesce, go. And simple workflow will coordinate that globally or within a region. So yes, we can absolutely do that. That would be inherent in the process. Good. Yes, sir.
So I've got a Postgres database running on EC2.
You're moving that to RDS tomorrow, right?
Yes.
PostgreSQL for RDS this morning?
Woo! That's wonderful and all, but the limits of that are 30,000 IOPS, and we might exceed that, so we'll see.
Ooh, that's hot stuff. All right.
Beside the point. So you suggested doing RAID 0 arrays on top of EBS. Mm-hmm. That's great and all, but obviously you exponentially increase your failure rate of your array, and as somebody else mentioned. And that really freaks me out for a production database. What do you suggest?
Snapshots.
Well, snapshots of production transactional data kind of get
all right.
iffy.
So here's, and I'm doing an NFS and CIFS talk tomorrow, where we're going to talk about this architecture. There's an architecture I like, where you take, for example, ephemeral drives, really fast ephemeral drives. Imagine those new I2 instances, 350,000 4K IOPS per second, incredibly fast. But they're not very durable. So we need a way to increase the durability. I use DRBD. Does anybody else here use DRBD? Okay. Yes. I use DRBD in C mode, which is asynchronous replication, from my really fast EBS, my PIOPS, to slower EBS, and then I snapshot the slower EBS. That asynchronous replication on a HI1, I can't get it to run any more than about 15 seconds behind. So that would expose you to 15 seconds of potential data loss. But then you have 2 copies on 2 different sets of EBS volumes, and you can snapshot the second one.
So DRBD obviously running to a different availability zone.
Yes, yes, absolutely. Absolutely. Different availability zone, yes. Yes.
Thank you.
All right, thank you. Yes, sir. No, you are not. So the question is, if I take a snapshot of a volume, a PIOPS volume, am I eating into my available PIOPS during the process? You are not. You are going to get a little bit of a slowdown. Okay? Probably 5%-ish of a slowdown, but that doesn't count against your SLA, and you still have all of your IOPS available. Okay? If you really, really need a certain performance even during snapshots, over-provision your PIOPS by about 10%, and then you'll be good. All right? Yes, sir. Sure. So I don't have something complete enough to show. The idea is that we want to make it easier to restore specifically arrays. So this is fairly simple. The command line tool that's going to allow you to restore arrays does an EC2 describe snapshots, gets a unique list of source instances and source arrays, and then it says, I have array MD0 from instance so-and-so to what instance would you like to restore it, and it gives you a list of all of your instances. You pick one, you press enter, and it attaches all of those arrays, all of those volumes, and then does an MDadmin scan create. So that's the way that would work. The goal is to make it easier to restore arrays of snapshots. Does that make sense? Okay, good. Dead Mouse is in 1 hour and 45 minutes, so it's time to wrap this up. Other questions, guys? No, we're good. Thank you all very, very much for your time. Give me a couple of minutes, I'll be out front for questions.